Okay, so these videos should not have a glare on them because I'm doing this earlier in the day. It's the weekend, and the light's not on the ceiling, so there shouldn't be any glare. But these videos, we're starting a new unit right now about antiderivatives and integrals, which we have acknowledged in earlier videos, but now it's time to finally say it. So an antiderivative and an integral are basically the same thing. And basically, it's the opposite of a derivative. So if you had the function f of x, the derivative of that would be f prime of x. The antiderivative of f prime of x is f of x. You're taking a step back. So knowing the graph of the slopes, you can figure out what the original graph is. Now, there is one little problem with this, which is what a lot of problems are going to be testing you on, and that is that if we have a function like f of x equals x squared plus 2, and then we took the derivative of that, you would get f prime of x equals 2x, and then the 2 would go away. But that means that if you're just given this information right here, that f prime of x is 2x, well, you can think, well, then instead of taking 1 away from the x and multiplying it here, and then multiplying the coefficient in the front, divide, or put the x up a power and then divide by with that. So it would be x squared, and then it would be 2 over 2, which would be 1. But that means that there was that 2 here originally, but the 2 isn't there anymore. That's because the constant here, no matter what constant's there, is going to disappear when you take the derivative of it. So that means that when you take the antiderivative, this could be anything. So you're going to say plus c. So whenever you're doing the antiderivative or the integral of something, as long as it is an indefinite integral, and I'll tell you what that means in a second, you're going to have a plus c at the end of it. Okay, so that, and if you think about this graphically, let's say that this is our graph of f prime, and this is y equals 2x. Every point, the slope goes up twice as much. So we know that this is the original graph, but if it was, instead of starting at y equals 0, if it started at y equals 5 or something, the slopes would still be the same. It would just be shifted up and down. So for that reason, the plus c at the end could be any constant, and the integral still makes sense. So the format for writing integrals is you write integral sign. It looks like this. And then you write the function, so in this case we would do 2x, and then you have to put what you're taking the integral in respect to. Kind of how when we did derivatives, we would do dy the function over dx because you're taking it in respect to x. So for an integral, if you want to find this integral in respect to x, then you would have to write a dx at the end. So it looks like that. So 2x, the integral of 2x dx equals x squared plus c. Must always have that c at the end, and most teachers will take off if you don't put a c at the end. Alright, so I just want to do one more problem just to kind of get your mind working here. There are, the next video we're going to talk about something called U substitution, which is going to kind of be a reverse chain rule. But sometimes you can look at problems and think that they're more complicated than they really are, and simplifying it is the easy option. So let me just make sure I have this written out right. We're going to find the integral, really quickly, of cosine cubed of theta all over 2 minus 2 sine squared theta. And then we write d theta, because we're taking it in respect to theta. So, well, with this one, we can think, oh, well, if we pull out the 2, I'm just going to do it right on here, but you'd have to show every step along the way. But we can make this 2 times 1 minus sine squared theta, which we know is just going to be cosine squared theta, and then these will cancel out, and you'll end up with the integral of 1/2 cosine theta d theta. Now, a wonderful thing about integrals, similar to limits and things we discussed earlier, is you can pull out coefficients, so it'd be 1/2, and the only coefficients you can pull out are numbers. You can't pull out variables or anything, but it'd be 1/2, and then the integral of cosine theta d theta, which would be 1/2 sine theta plus c. You may be wondering, why aren't you doing 1/2 c, or like c over 2, because there's a 1/2 in front. You can do, wait, that was not right. You could do that, But the truth of the matter is C is any number. It could literally be any number. So 1/2 times any number equals any number once again. So 1/2 C, C squared, all that stuff will always just equal C. And yeah.